All right, so today we're going to be talking about equivalent ratios, which we talked a little bit about in our chocolate milk problem. And I'm also going to show you ratio tables, which we also talked a little bit about in our chocolate milk problem. First, let's get a definition going for equivalent ratios. EQU. Equivalent ratios have the same ratio or numbers in simplest form, just like fractions. And you can find equivalent ratios by multiplying or dividing. So you want to look for the greatest common factor when you are looking for how to make equivalent ratios. And that's how we make them down into simplest form. I'm going to show you an example. And how do we, okay, so how do we know that 3 to 4 how do we know if, 3 to 4 is equivalent to 6 to 9? And it's just like what we do with fractions. I turn this into simplest form. I find a factor that goes into both 6 and 9. So I'm going to divide both 6 and 9 by 3 because I know 3 goes into both those numbers. So 6 divided by 3 is 2, and 9 divided by 3 is 3. So 3 to 4 is not equivalent. And here you have our not equivalent sign. So you're going to come across some problems that ask you if they are equivalent, and you have to break them down into simplest form. I'll give you another example of a number that's greater. So 4 to 24 and 8 to 48 equivalent. So let's break them down. I know 4 goes into 4 and 4 goes into 24. 4 goes into 4 once. 4 goes into 24 6 times. 4 times 6 is 24. And then 8 and 48 is divisible by 8. 8 goes into 8 once. 8 goes into 48 6 times. 6 times 8 is 48. Are they equivalent in their simplest forms? They are. So we write yes. Sometimes we will have ratio tables, and they are looking for equivalent fractions as well. So I'm going to show you an example of a ratio table. And I'd like for you to draw it out. Here we're going to keep track of the number of bouquets of flowers. And this is going to be the number of daisies in our bouquet. And this will be the number of tulips in our bouquet. And so you can see this is our ratio table. So for every one bouquet, I'm going to have to find the number of daisies and the number of tulips. For every two bouquets, I have 24 daisies and 12 tulips. For every 3 bouquets, I have 18 tulips. So what we're looking for are the relationships between the two numbers. So if I have 2 bouquets and I get 24, what am I doing to 2 to get 24? What am I doing to 3 to get 18 and 2 to 12? What am I doing to 2 to get 12 should be the same thing of what I'm doing 3 to get 18. So 12 divided by 2 and 18 divided by 3 should give me the same answer. 12 divided by 2 is 6. 18 divided by 3 is 6. So I'm multiplying 2 by 6 and 3 by 6. So that means 1 times 6 gives me 6 tulips. Now I'm going to find the answer for daisies in 1 bouquet and daisies for 3 bouquets. So what do I do to 2 to get 24? I multiply by 12. 2 times 12 is 24. So I'm going to do the same thing to 1. 1 times 12 is 12, and 3 times 12 is 36. So daisies to tulips should all have the same equivalent ratio at the end. These can be broken down even further. 12 to 6 is a 2 to 1, which means 24 to 12 and 36 to 18 should also be 2 to 1, which is true. 12 times 2 is 24, and 18 times 2 is 36. So all of these are equivalent ratios. We know for sure because in their simplest form, they are all equal. And ratio tables can show you that they are all equal. And we know that we have that relationship. What we do to the number of daisies, we do each time. What we do to the number of tulips, we do each time. We're looking for those relationships. And in this ratio table in particular, we can say there's a relationship this way, and a relationship from 1 to 12, 2 to 24, and 3 to 36. Look at those number relationships. One more thing I want to go over with you is sometimes there will be more than 2 numbers, and I have to move my paper because I'm out of room. And we'll have 3 numbers. And those 3 numbers have to be equivalent as well. So I'm looking for an example. You know what? I don't see examples of 3 numbers yet, so I'm going to leave that off until our next time. I am, though, going to give you a problem that has to deal with measurement. And those measurement problems mean that you have to be able to convert one to the other. And what I mean by that is that page 276, we're going to go ahead and copy that into our notebook tomorrow. I'll make a copy of the page and we'll go ahead and cut it out and put it into the notes section just so we have it to help us with conversions. And here is our example problem to help us with our conversion. Seven kilograms to 21 grams. So here's our ratio. Now, automatically I would think I'm going to simplify this by 7 because I know 7 goes into 7 and 7 goes into 21. But before I even get that far, I have to make kilograms and grams the same. So using my handy dandy page 276, I look down here and it tells me 1 kilogram is in every 1,000 grams. 1 kilogram is in every 1,000 grams. So I've got to do something to this. Which one is bigger? So my ratio of 1 kilogram to every 1,000 grams. I've got to convert them. What am I going to do? Well, I've got to make them both grams. That would be the easiest way to solve this problem. So I'm going to turn 7 kilograms into grams by multiplying it by 1,000. And that takes 7 kilograms and turns it into 7,000 grams to 21 grams. So now they're both in gram form and I can continue with my simplification. I'm still going to divide them both by 7. So my simplification is 7,000 divided by 7 is 1,000 grams. 21 divided by 7 is 3 grams. This is simplest form. Here it is, simplified. Let me see if I can find another example problem to show you with conversion. So, example 2 is going to be simplify it. and I'm going to use 26 centimeters with 4 meters. And I know that can be simplified because these are both length. So I'm going to look at my handy dandy page 276, which you'll have in your notebook tomorrow, but for today I'm going to show you. And it says for every meter, every 1 meter, there are 100 centimeters. So I'm just going to write that down. For every 1 meter, there are 100 centimeters. Which means for every 100 centimeters, there is 1 meter, which follows centimeter, meter. So I'm going to turn my meters, which are bigger, into centimeters. So I'm going to multiply this by 100, and I'm going to get 26 centimeters for every 400 centimeters. And now that they're both in centimeter form, I can simplify. 26 and 400 are both even, so I'm going to start by dividing them both by 2. 26, 2 goes into 2 once, 2 goes into 6 3 times. 13 centimeters. 2 goes into 400 2 times. 13 is prime, so I can't go any further. This is simplest form. So that's basically everything I wanted to go over with you for today. This is equivalent ratios and ratio tables. It's just another step. Again, we're going to keep going. There will be more notes on ratios as we get a little bit further into the chapter. Your to-do to practice the skills you just learned, I'm going to have you fill in a ratio table. So I'm going to give you some blank spaces to fill in. So we're going to put number of days here. And earnings, how much money was made. And, oh, this is going to be Selena. And this is going to be Drew. Okay, so this shows Selena makes some money and Drew makes some money. And this is going to say the number of days that they worked, how much they made. So, day 1, Selena made $31 and Drew made $33. Day 2, Selena made $62. Drew made $66. Now I want you to fill in for day 3, day 4, and day 30. So if you understand what to do from 1 to 31 and 1 to 33, you can figure out what to do to get from 30 days to Selena's earnings and 30 days to Drew's earnings. Follow the pattern. And then we'll discuss it when you come in tomorrow. That's it for today. I hope that was not too difficult. Again, I will have page 276 ready for us to cut out and glue into the note section of our notebook in order to help you with the conversion problems. See you tomorrow.